Hi, in this video, we're going to cover the answers for Module 15 review. And let's begin with number 1. What logarithm equation is equivalent to b to the x equals y? So if we recall that a logarithm function with the same base of b can be written as b log b of y equals x, and you can understand this much better when you follow the arrow. So you can see that when b is raised to the x power, you will get y back. And so this is the equation with logarithm. And number 2 is the reverse. What logarithm equation is equivalent to this log equation? And again, with the arrow, it's much easier to identify. We can rewrite this as 3 to the c equals a, and that will get rid of the log. So that's the equivalence. Number 3, let f of x equals log of 4. What are the values of each one of these? So we're going to do them as 3 separate problems. So we'll call this A, B, and C. So in problem A, we're looking for f of 1/4. So we're going to evaluate log of x. Whatever x is, we're going to let it be 1/4. So that will be log of base 4 of 1/4. And we're going to solve for it by letting it equal to x. So we're going to raise the 4 base to the x power is equal to 1/4. And we're going to rewrite the 1/4 as 4 to the minus 1. Therefore, because the base are equal, we have exponents are equal. So x will equal to -1. And for part B, same thing. 64, we're going to let x equal to 64. So log base 4 of 64 is equal to x, and we will follow the arrow. 4 to the x equals 64, and rewriting 64 as 4 to the third. Therefore, base are equal. We have exponents are equal. X equals 3. And the last problem, when x is equal to square root of 4, it'll be log base of 4 to the square root of x equals x. Again, following the arrow, we have 4 to the x equals radical 4. And now we're going to rewrite the radical 4 as 1/2 power. Once again, base are equal, so x is equal to 1/2. So that's how you solve those 3. Make sure you guys follow through with showing the work and understand every step. Number 4, which function is the inverse function of 7 to the x? Once again, inverse function of an exponential involves log. So looking at the equation, A does not involve log at all. And then we need to find the one where the base is 7. So the log will remain a base of 7. So C is the only one that has a log base of 7. So that is going to be the inverse. Number 5, answer the questions about the function g of x equals log 5 of x. What is the domain? So as you can see, there is no other values with the x. So the x, which is represents the domain, is that x, the only restriction we have for logarithm is that x cannot equal to, it cannot be 0 or negative. So our restriction is that x is greater than 0, or you may write it in infinity form from 0 to infinity. So both of these are acceptable. And this is the set notation right here, if you use the brackets. Number 6, what is the range of the function? As you know, any logarithm function goes in this shape, and so there is no restriction to the range since it can extend all the way up or down. So the range is the set of all real numbers, or you can use -infinity to infinity to represent that as well. Number 7, describe the end behavior of the function. So in a logarithm function, as you can see, we have a vertical asymptote here at 0 at the y-axis. So as you move towards the left side, it's kind of like a block wall. You cannot pass this x-axis. So that would kind of like be where the block wall is. That's the vertical asymptote. So as you move to the left side, you are moving down to the infinity. So you're approaching negative infinity. On the 0 side, this is where x equal to 0. So if you're looking at it from the right-hand side, that's from the 0 positive side, the function is approaching negative infinity. And then as you move to the right-hand side, the function is just going up to infinity. So the one that fits the best description of this would be C. As you move to the x on the right-hand side of 0, the function is going down. As you move to the right-hand side of x, the function is going up. So that would be the most appropriate answer. Number 8, to graph this basic function, as you can see, there is no transformations whatsoever with this. So this is the most basic type of graphing. So we're still going to involve using the reference points. So the reference points for logarithm function is 1, 0, and then b1. So the base is actually 2, so it will be 2, 1. And then x and y does not change. So whatever x and y are, those will be the same value. So we're going to just graph 1, 0, and then 2, 1. So think of this as a vertical asymptote. So your graph is going to go towards the vertical asymptote and then goes up. So this is how the graph should look like. Number 9, use a calculator to find the value rounded to the nearest hundred. So you should be able to use your regular calculator, just crank in the numbers, and you should get to the nearest hundred, which is 2 decimals. So the log of 20 should be about 1.30. Natural log of 0.5 should be negative 0.69. And then the natural log of 0.5 is negative 0.60. So make sure that you guys practice with your own calculator to get the same answers here. Number 12. This is the exponential function models the decay of 50 grams, so initial value of 50 grams, of radioactive isotope over time, T, in hours. How long does it take for the amount of isotope to reach 25? So basically you want to know how long it takes to decay to the 50% level, half of the original. So we're going to let the function equal to 25 grams, starting with 50, and then the same equation. And we're going to divide 50 to solve for the equation on both sides. So we have 2 is equal to e to the negative 0.04 t. Now in module 15, you should still be able to use decimals to solve this equation. But if you use the skills, so you can from here on go ahead and use decimals to solve. Let one side equal to y equal 2 and one equation be the right hand side. Or you can apply the skills that you learned in module 16 to solve it by taking the natural log of both sides. So you have natural log, excuse me, this is 1/2 right here. So natural log of 1/2 or 0.5 is equal to negative 0.04 t. So one way is use decimals, 2 is to solve it with the logarithm skills, the logarithm properties, and then finally divided by 0.04 on both sides, negative. And that will give you t, which is approximately 17 hours. So that's the final answer. Number 13. pH is given by this formula where H plus is the hydrogen ion concentration in moles per liter. What is the pH of a liquid with hydrogen ion concentration of 1.5 times 10 to the negative 9? And so we're going to just use the existing formula for pH and then substitute the hydrogen amount in here, which is 1.5 times 10 to the negative 9. So it's just a matter of evaluating the property. So you're going to use your regular calculator, enter 1.5 and then do the 1 over function, then take the log of it. So you should have approximately 8.8 as an answer. Number 14. What transformations on the graph from the original to this new equation? So we can see based on the equation that there should be a vertical stretch factor of 3. And then also with the x, there's a plus 10, which indicates that there's a 10 unit to the left transformation. So based on those two, the best answer is A. Number 15. Describe how to transform the graph from here to here. And as I told you, there's a typo here. There should be a negative in front, and this base should be 5. So based on that, the two transformations are reflection across the x-axis, and then also 2 units down. Number 16, the parent function is f of x equals log 3 of x. Which function is graphed on the coordinate grid below? So based on the equation, it looks like this is a log base of the original. Looks like it moved 3 units to the right. So, and then also there is looks like it was shifted down. So 3 units to the right, 1 down, and so that is answer choice B. 17, what is the domain? And if we are looking for the domain, basically again, we are solving the inside and letting it greater than 0. So we will subtract 2. We have negative x is greater than negative 2. And then when we divide by negative 1 on both sides, we will need to change the direction. So it will become x is less than 2. And so the one that matches the same as less than 2 would be A. That's a x less than 2. So this is x less than 2 right here, from negative infinity to 2. Number 18 through 20 has to do with the table set. So you need to go ahead and open up a tab in decimals and enter x1 and y1 into the table. And first, number 18 says which function is an exponential model. So you would need to generate the equation using the exponential function on decimals. And so make sure you guys try that first before you look at the answer. And here is the equation that I have. A equals 1000, B is 1.5 exactly. So put it together, your equation should be C. That's the answer. And then number 19 says use a logarithm regression on a graphing calculator. Find a log model for the time as a function. And so just to kind of remind you, the two equations for exponential for regression line is y1 approximate a b to the x1, right? So for the log function, it's y1 approximately a plus b times the natural log of x1. So that would be the logarithm function. So if you use that, you should be able to obtain the equation. But switching, you need to switch for the logarithm because it is the inverse of exponential. So you will need to switch the x and y. So instead of making x the first column, x is going to be the second column. So you're going to make this x1 and this is y1 for your equation. So if you watch carefully on my next picture, I've switched the x and y. So this is what the graph that I generated, the equation should look like. A is negative 17.03 and then B is 2.46. So let's go ahead and write down the equation for number 19. T is equal to negative 17.04 plus 2.471 times natural log of x. Okay, or you can use log of x. Either one is fine. And as you can see from the graph earlier, the graph looks something like this. So make sure you guys get the correct equation from the decimals calculator. Okay, and that's the end of this worksheet. Have a great day.